So I'm going to assume that you guys have done the problems now, so we'll go ahead and walk through them. So this first question is basically given a function f, write the recurrence that corresponds to it. So to start off with, we see that we have a base case when the input n is less than or equal to 1, and our base case just returns 0, which is a constant time operation. The next part of our recurrence is going to be this iterative step that we add to our recursive call. So basically, we have a nested for loop where the bound I goes from 0 to n, and our inner for loop goes from 0 to I. So if you actually write out the summation for this, it turns out that this is equal to the Gaussian identity, and it's also one of the problems we did earlier in section. So it turns out that the amount of work that's being done in these two for loops is n times n minus 1 over 2. So onto the actual recursive calls, we see that we have a call to f of n over 2, a constant addition here, another call to f of n over 2, another one, and another one. So in total, we have 4 calls to f of n over 2. And I should also point out that if you multiply by 5, or if you multiply by 2 here, those don't affect the actual number of calls that we get. Those are just taking the results of the call and doing a constant time multiplication. So the final recurrence that we actually get from the function is t of n equals 1 when n is less than or equal to 1 for our base case. And for our recursive case, we have 4 times t of n over 2 plus n times n minus 1 over 2 because we had that nested for loop.